So I'm going to talk about some more problems from section 2, and I'm going to start with problem 75. Now 75 asks us to do some graphing, and the problem says to graph this. Now we can talk about a few things very quickly. First of all, because it's an odd degree and the leading coefficient is positive, we know that it's going to end up here and it's going to end in this direction down here. Not necessarily on the graph there, but we know that it's going to follow this pattern as you go right and follow this pattern as you go left. If we want to talk about specific things with this, we need to talk about the zeros, or where it crosses the x-axis. So if I set it equal to 0, we're going to say that, well, this has a GCF of x, so I'm going to factor out x. So I'm left with x squared minus 25. That's even further factorable, so it's x plus 5 times x minus 20, or x minus 5. So I have three zeros: 0, plus or minus 5. So I'm going to mark those. Now I know it's got to come from this direction and go through, so I'm going to just draw this coming through this direction and see what happens at, let's say, -2. So if I cube that, minus 25 times -2, I get -8 plus 50, which is a positive 42. It's way up here. So we know that it's going to go way up here, but it has to come back down because it has to be a smooth curve. And if I plug in 2, if I plug in a positive 2, what I'm left with is 8 minus 50. That's a negative 42. So that's got to come way back down, and then it's got to come back up through here and go back up that way. I didn't draw it perfectly straight, but it's going to come back up in this direction. So it should look something like this. So there's your graph for 75. Now for 77, it's a little bit different because when you look at it, you have different variables, and the variables are trying to throw you off, but again, it's just in terms of a different variable. It's nothing different. So if you try to see this, first of all, the leading coefficient is positive, because if you distribute this, it's going to be a 1/4 t squared. So it's going to end positive in both directions because it's an even power. If you try to factor this, you can't factor it. So you're looking for where this is equal to 0. You would get something like this: t squared minus 2t plus 15 equals 0. Well, we have some options on how to get that equal to 0. You can try factoring, but you won't come up with any answers that add to 15, but add to -2 but multiply to 15. Now, if you use the quadratic formula, you get this. Hopefully you can see here that 4 minus 60, you're going to get a negative square root. So there are no real zeros. Well, that doesn't help us either. So now we have to start from the beginning. Where is the vertex of this quadratic? Okay, so we need to know where the vertex is of this quadratic. So the vertex is going to be at -b over 2a. Well, -b, which is 2, or excuse me, a negative 2 times a fourth. So that's really a positive, or excuse me, a negative 1/2. So this is going to be a positive 1/2 over 2 times a, or 1/4. I got these because we times these by a fourth. If you take a half times a fourth, you get 2. So your vertex is going to be equal to 2, at least for the x or t coordinate. Now I got to plug this in to see what I get back. 2 squared is 4, minus 4 plus 15. That's 15 times a fourth. That's going to be 15 over 4. So I have to go to 2 comma 15 over 4. That's 3 3/4. Now this is going to be a parabola that opens up, so I'm just going to pick another point and just see what happens. At 1, I get 1 squared minus 1, so negative 1 plus 15. That's going to be 14 times a fourth. That's 14 over 4. To properties of symmetry, this will also be 14 over 4. So that's just moving it in 1/4 of a direction. Sorry, I made one minor error here. I put 1/4 here because this was going to be 1/4. But it should be 2 times 1/4. So that's 2 times a fourth, which is actually just going to be a 1/2. So the vertex is actually at 1. So I did all of this to find the vertex. So at 0, this should be 15 over 4. So at 1, it's right here. At 0, it's 15 over 4. So it looks something like this. So I just made a slight error by not putting the 2 in right away. And the number I got would have been right, but I just used symmetry with the wrong point here. If I plug 3 in, let's make sure I do that right here. If I plug 3 in, well, I can leave that for class if somebody has a question about it. If I look at 93, 93 says use a graphing utility. No, actually, no. Does it use it? Nope, it doesn't use a graphing utility. Sorry. So it says use the intermediate value theorem and a table feature of a graphing utility. So it says use a graphing utility. So when it says use a graphing utility, we do not need to worry about this. About that. Do not worry. So that's not an issue. So what I want to quick jump to then is real quickly is a problem that I didn't have in the checkpoints that I'm just going to add. It's problem number 68. So what it says is that we have a polynomial that has the given zeros. So we have this 0, negative 2, and we also have a 0 of 4 and 7, and it says we want a degree 3 polynomial. What's what it says when it says n equals 3. So we want a degree 3 polynomial with these zeros. So what that means is that we want equations that give us these answers. And the way that we go about solving these, that we can then backtrack and say that, well, if we have that as a 0, then this has to be true. If we have this as a 0, then this has to be true. Same thing goes with this one. So if all these are zeros, if we multiply them all together, they all multiply together. One of them would have to be 0. So then you have to use your multiplication abilities and multiply these all together to see what the polynomial would be. So if I multiply the first two things together, I get x squared minus 4x plus 2x minus 8, or x squared minus 2x minus 8. Then from there, I take that whole thing and times it by x minus 7. So I'm going to times this all by x minus 7. And what I'm left with is x cubed minus 7x minus 2x squared plus 14x minus 8x plus 56. So I combine like terms. I get x cubed minus 9x squared plus 6x plus 56 for my answer for this expression.